All right, now we're going to look at probabilities from tables. So we're going to have some tables and we want to find specific probabilities from them. This one is a table of a large shopping store that gave details on how their customers paid for their items. So you can see the breakdown here for each type of card. And the rest of the people paid cash. So if I put cash out here, what probability to use cash? Now, a whole sample space should add up to a probability of 1. So what we do is we sit and we start by adding up all of these numbers, where we have 0.3 plus 0.12 plus 0.15 plus 0.18, and these four add up to a probability of 0.75. So if the rest of the people use cash, 1 minus 0.75 is 0.25. Now, so knowing this, that cash is 0.25, what is the probability that they use Visa or MasterCard? So Visa or MasterCard. Now there's nothing in between here. They can't use Visa and MasterCard. So what we do is we add up these two values, 0.3 plus 0.12, so we get a grand total of 0.42. Find the probability that a customer used a Visa given the fact that they used a credit card. So this is the probability they used Visa given the fact that they used a credit card. Now, we already added these up, and we said that that's 0.75. So out of the total of 0.75, what the probability is Visa? That's 0.3. So out of all of these, what's that probability? So now this doesn't look good as a fraction. So what we do is we take 0.3 divided by 0.75, and we get a probability of 0.4. All right. So now this is a little bit bigger table, and we have 3 events that we brought out of this. So we have this table of grades that people got, A, B, below B, and what type of course it was in. So so you can see the data, and now there's some events. The event is the grade was an A, the grade was a B, or it comes from a liberal arts course. So we're going to take and we're going to find all of these probabilities. Got to format this a little bit. All right, so what's the probability that A occurs? So I filled in the marginal distributions to make this a little bit easier for us. The probability that you get an A, well, that's 3,392 divided by our total 10,000. So that's what, about 0.3392. Now, what's the probability that somebody gets an A and they're in a liberal arts course? So that is they have to be in both those columns. So that's 2,142 out of 10,000. So that's about 0.2142. Nice that we got a nice even number. Now it starts to get a little trickier. What's the probability that they got an A given the fact that they were in a liberal arts course? So now we assume that they're in a liberal arts course. So I'm narrowing my sample space to just these values. So out of these people, what's the probability they got an A? Well, that's 2,142 out of, now the grand total is 6,300. Now when I take those numbers and divide them out, I get 0.34. Now let's move on to these next few. Now we want to find the probability that they got an A given the fact that they're in a liberal arts course. So probability they were in a liberal arts given the fact that they got an A. I said that backwards, but so they got an A. So if we're just looking at these people, what's the probability they were in liberal arts? That's 2,142 out of our grand total of 6,300. Oh, my denominators, hopefully you're seeing that's not right. It was 3,392 because we're looking out of this total. So when we divide those out, 2142, 3392, we get 63%. So 63% of the A's come from a liberal arts course. Well, what's the probability that they got a B, or the grade is below a B, if assuming they come from a liberal arts course? So below a B is here. And assuming that they came from a liberal arts course is this sample space. So below a B would be 2268 out of our total for liberal arts, which is 6,300. 2268 out of 6,300, that's 0.36. And now what's the probability that it's a B and L? So that it's below a B and it's from a liberal arts course. That's 2,268. And this is out of our total, which is 10,000, because we haven't reduced our sample size with a given. And so this is 0.2268. All right. Hopefully that makes sense and you can do the on your own.